Hi everybody. Today we are working on understanding the limit and algebraic approach. We did graphical approach, we did analytical approach, and now we are doing algebraic approach. Analytical approach was those tables, if you guys remember, and graphical was from the graph, and algebraic now we're going to use algebra to do the limits. So there are a few steps that you have to follow it for algebraic expression. Okay, I'm going to write down all these steps over here and make sure that you follow them. Okay, the steps. 1, plug in whatever the value is x approaching, plug in like a direct substitution. If you get plug in, if you get 0 over 0. Okay, when I say plug in, you're going to plug in whatever x is approaching, and you are not going to pay attention whether it's from the left, from the right. We will consider left and right, or if there is no left and right, we will consider this later. But in the first step, whatever x is approaching, either x is approaching 0, x is approaching 0 from the left, x is approaching 0 from the right, you just have to plug in that 0 there, okay? If you get 0 over 0, then it means you need more work. 0 over 0 means more work. What is that more work? More work means you're going to factor the function if you can, right? It depends on the factor. It depends on the function. You factor if you can. Find the least common denominator if it's a fraction. Do conjugate if you have like square roots, then you can use conjugate. If you factor least common denominator, conjugate. Distributive property, use distributive property if there is something FOIL, like remember the FOIL. So I'm just going to write distributive property. So use distributive property. Okay, only all this more work you need if you have 0 over 0 by direct substitution. Second step, if you get, for example, again plug in, and if you get number over 0, like undefined, you know, like undefined function, like when after direct substitution you get something undefined, then you have to do limits. Whether they are telling you to find limit left and right, then you just follow the left and right. But if they don't say anything, you know, when if they don't say anything left and right, then it means we have to find both. So you have to do limits using arbitrarily close number. Arbitrarily, I don't know if I spell it right, but arbitrarily close numbers. Okay, you can pick arbitrarily close if they're asking left, if they're asking right, arbitrarily close. And then when you get the arbitrarily close, you're going to plug it in again. You get arbitrarily close numbers, you plug it in again. Now, when you plug in again, I'm going to write there, plug in again. You're going to pick arbitrarily close numbers, and those are the one you're going to plug in again. Now, all we are interested in when you plug in, all we're interested if we have a negative number or we have a positive number in the bottom. We really don't need numbers, we need signs. Plug again, then we need signs. Like really, I mean, you don't need numbers over there. Like when I plug in again, I will get some numbers, but not interested in numbers. I need negative sign or positive sign, or maybe I can get positive, or I can get negative top and bottom. So when I get all of those, then it means this one means I have negative infinity. That one means I have positive infinity. This one means again I have positive infinity because they cancel out. So anytime when you plug in and you get number over 0, you should know that your answer must be, okay, your answer must be positive, negative, infinity, or you can say does not exist if they are from the both sides. Okay, so let's repeat this again. First step, you plug in the number. If you get 0 over 0, you need more work. What is that more work? All of these things: factor, else least common denominator, conjugate, distributive property. Second, if we don't get 0 over 0, we get number over 0, which means undefined. Then you have to do limits using arbitrarily closed numbers. So you're going to pick arbitrarily closed numbers, plug them in again. Now this time when you plug it in, I'm interested in signs. We need signs. We do not need numbers, okay? Because our answer must be positive, negative, infinity. So we don't need answers. We don't need numbers. We need signs. So that's how it's going to go. When we do examples, it will make more sense to you guys. Okay, let's do examples. Write it down, memorize it, do something. You just have to know this, all these steps, and that's what we're using for algebraic expressions. Okay, let's try. Consider the function f of x half absolute negative 2x plus 4 minus 4 for a moment. The graph of fx is pictured below. From the graph, determine the following limits. So up here, I'm doing algebraically, like I'm plugging in the 0 in this function. Like, do you see? Limit x approaches 0 f of x. And technically they are asking find f of a. So you know a in this case is 0. So I'm going to plug in that a 0 in this equation. When I plug in that 0 in here, I'm getting f of 0 equal negative 2. Right? When I plug in 0 here, that would be 4. Divide by 2 is going to be 2. 2 minus 4 is negative 2. Now we're going to do the same thing. Limit x approaches 0 f of x. So here is the 0. Okay. And I'm approaching 0. And since they didn't mention left and right, then I have to do both. So this is 0. I'm using the graph from the left side. When I approach 0 from the left, right there, 0 from the left, then I'm getting negative 1. When I approach 0 from the right side, I'm getting negative 1. It's not negative 1. Actually, it's negative 2. Okay, let me see this one more time. Okay, I'm approaching 0. That is 0 from the left. And this is not negative 1 because 0, this is negative 1 and negative 1. Like, do you see the x is negative 1, negative 1? So I was wrong. You're going to go from here, approaching 0. Approaching 0 means what is the y value for it? So literally I'm approaching y value for that 0. So approaching 0 from the left is negative 2. Approaching 0 from the right, again, it's negative 2. So I'm going to write this: limit x approaches 0, f of x is equal negative 2. Now let's do plug in this one too. They said f of a. So in this case, I just have to plug in. Remember I said don't pay attention to the left and right. And they're asking a y value anyway. So plug in that 2 there. When I plug in 2, I'm going to get f of 2 equal negative 4. Negative 2 times 2 is going to give me negative 4. Negative 4 plus 4 is 0. 0 times half is 0. And I'm left with minus 4. So that's negative 4. Let's do approach that one. X approaches 2 from the right. You see they said right. So I have to go from the right side for 2. So this is my 2. And I'm approaching 2 from the right side. And this is my right side graph. When I approach the y value of 2, it's negative 4. Let's try 10. 10 is, if you guys pay attention, I'm approaching 10. So do you see on the graph, I don't have a 10. So when I plug in f of a for 10, let's do that first. F of 10, it is giving me 4. So negative 2 times 10 is negative 20, plus 4, negative 16, and then divide by 2 is negative 8. Negative 8 or positive 8 because it's in the absolute. And then I got, what did I get? 4. 8 subtract 4 is positive 4. Now, do you see I don't have 10 up here? I can't see it. But since we already know when we do the direct substitution, we are getting some number. So I'm going to go limit x approaches 10 of f of x is also 4. And if you extend this to 10 and it goes in this direction, then I approach 10, it's going to go to 4. You see, this thing is going to go up there. Then that would be 4. But in case in the graph I don't have it, then since I already know by direct substitution I'm getting answer, so I did the direct substitution and I got 4. Okay, let's try this. When a function is defined and continuous at the value x equal a, how can limit x approaches a f of x be found analytically? Okay, so define means in continuous. Define means when there is no whole, vertical asymptotes or horizontal asymptotes, any of this. Continuity, like this function, is also continuous in defined because each and every x value has a y. That's a defined. Closed circles. Okay, so how can limit x approaches f of x be found analytically? Okay, so you're gonna go limit x approaches a of f of x is equal limit, I'm sorry, not limit, is equal, okay, that was pink, is equal f of a, like we did on the top, provided f of x is continuous at x equal a. If you guys pay attention, that's exactly what we did in the 3 questions. Like this, all the limit approaches a is exactly the same as a y value when I plug in direct substitution. So my y value, my defined points, all these defined points are equal the limit approaches to those numbers. So when that happens, then it means the function is continuous. There is no whole, no undefined points or anything like that. Okay, so let's try these questions and using our steps. Okay, we're going to do direct substitution. So when I do direct substitution, and guys remember this, when I said when we do the plug-in, if you get 0 over 0, if you don't get 0 over 0, you get some number, that is your limit. Like I talked about this, like f of a and limit x approaches a are exactly the same. If they are exactly the same, then the function is continuous. Okay, so I'm going to go direct substitution for this one. Let's try. Equal half, I'm going to plug in 3, okay? And this 3 means limit x approaches 3 from left and right both. But remember, we do direct substitution first, and this is algebraic approach. Half x is 3 squared minus 2, 3 plus 3. This one is going to give me, this is actually 3. Okay, so this is going to give me equal half times 9, 3 times 3 is 9, minus 6 plus 3. Now let's solve this further. This is going to give me 9 over 2 minus 3. When I subtract 3, that's going to give me minus 3. Okay, so now technically what is 2 times 3 is 6, and then I have a plus 3, so I got, yeah. So let's make a least common denominator here. My least common denominator is 2 in this case. 2. So that's 9 minus 2 times 3 is 6. So it's going to give me 9 subtract 6, which is 3. And you divide by 2. So your limit is 3 over 2. We didn't get 0 over 0 or we didn't get number over 0. So we're okay. What is the limit? 3 over 2. We're finished. Done. It's just a direct substitution first. Always when you guys see limit questions and you need to solve algebraically, like it's not graphically or analytically, it's algebraically, then direct substitution is the first thing. Always do it. Okay, so this is good. Let's try this. Again, this is 3, so I'm going to plug in 3. Let's use a different color. So I'm using 3. 5 times 3 plus 2 over, and by the way, on the AP test, guys, you have to do every question step by step, especially in free response. Multiple choice is kind of easy because you pick the answer. You have to solve it on a scratch paper and pick the answer, but on free response you have to give them step by step. Even if it's 2 plus 2, you have to show them it's 2 plus 2. That's how you got 4. If you don't show them, that's not okay. So please show everything step by step. So let's try this. 5 times 3, 15, plus 2 over 6 minus 3. 15 plus 2 is 15, 16, 17. Divide by 6, subtract 3 is going to give me 3. And I can simplify this. I don't have to change it to decimal either. If you want to, you can go ahead. And always in calculus on the test, you have to have a 3 decimal places. No matter what, 3 decimal places is important. You don't get points if you don't give them 3 decimal places. Okay, let's try this question. And direct substitution again. I'm ignoring this left and right part. I will do direct substitution first and let's see what happened. So I'm going to plug in 2 plus 2. They are both in the square root. Minus 1 divide by 2 plus 1. So this is 4 and it's a perfect square. So 2 minus 1 will give me 3 on the bottom. 2 and this is 1/3. So the answer is 1/3. Let's try this. Okay, these are trigs. Okay, so now we're going to use our unit circle. So let's try trig. First thing first, plug in. So I'm going to plug in that pi over 2 for theta, because limit x approaches, limit theta approaches pi over 2. So sine 2 pi over 2. You see that? This is an argument. By the way, any trig, when they have these numbers or the variables, whatever, this is, we call this argument. Okay, so you don't touch argument, you can't change it, you can't do anything to this argument. So just remember that. So this one cancel out. Then I have, what is it, sine pi, right? I got sine pi. Now let's find what is sine pi value in the unit circle. Okay, you guys should know already for the unit circle, sine means a y value. Cosine means is x value. Okay, so since I'm asking a y value at pi, first find the pi. This is a pi right there. This is the pi. And what is the sine value? Sine is y value, so which is 0. So your sine pi is 0. Done. Let's try that one. This one is gonna be limit theta approaches 2 pi over 3, and the function we have is cosine theta over theta. So I'm gonna do the direct substitution first. Cosine 2 pi over 3. Okay, I plugged in, that's the argument, and theta is 2 pi over 3. There. Figure it out first. First thing first, what is cosine 2 pi 3? Cosine is the x value, right? So find 2 pi over 3 somewhere first. 2 pi over 3. This is my 2 pi over 3. What is the cosine? Cosine means x value, which is -half. So the -half. You do understand these are degrees. We don't use degrees in calculus, but we're going to use the order pairs like this, x and y, and the radians. Okay, these are all radians. That's -half. In the bottom, 2 pi over 3 is going to stay as it is. Okay, what else I can do? You know, we do reciprocal things to make it simpler. -half times the division change to multiplication, and we do reciprocal, which is 3 over 2 pi. Simplify this further. -3 straight across multiplication, right? This is gonna give me 4 pi. Can I do anything with this? You can change it into a decimal. You don't have to, just leave it alone. Okay, if you're changing into decimal, 3 decimal places always. Okay, let's try this. Log. How do we do log questions? Again, direct substitution, it's a limit question, right? Before even I think about what is log, what is a trig, sine, cosine, tangent, I just say, okay, this is limit. Let's do direct substitution, and then we go from there. So it's going to be log base 8, 11 minus 9. For the x, I plugged in 9. So now I'm going to go log base 8. What is 11 minus 9? It's 2. Okay, plug this in the calculator. You should have a log base 8 2 in your TI-84 calculators or whatever calculator you are using. So just plug in this and you will get the answer 1/3 or maybe decimal. If it's decimal, 3 decimal places must. Okay, so let me change this to 1/3 into decimal. It's going to give me 0.33333, and I'm going to do, actually, why do I have this? Okay, so I'm going to do 0.333, like I said, 3 decimal places. So you're good. Okay, so that's how this whole thing is gonna work. Algebraic, it's not hard. In the next video, we will be actually using 0 over 0 and this number over 0, and I'm gonna make sure that you have this on the next video too in front of you while you're solving the questions. Okay, this is what it is, guys. And from now on, I'm gonna give you also a kind of classwork, homework kind of page. I'm gonna show you up here on the screen. You solve the question, like pause the video or something, solve the question, all of them, and then I will submit the video for that homework the next day. So you check the answers with me. Okay, any questions, comment below and I will help you out. Thank you so much.